Okay, so hi everyone. Thanks already for joining our session today called Predictive Analytics Made Easy with Tim. For those who don't know me, I am Neil Vets, managing partner of At Once, and I will guide you through today's session together with Sam Verdonk from TangentWorks. In case there is any disturbance, issue or question during the session, you can just use the Q&A window on the right for that, which will be monitored throughout this live session. So on the agenda for today, we will start with setting the scene and who is At Once, followed by an overview of the Tangent Information Modeler presented by Sam in this case. And to round up the session, we will provide a demo of Tim in a standalone environment, or called Team Studio, let's say, and how it is combined with ClickSense or any other data analytics platform. And lastly, we will have some time left for a Q&A. So first of all, let's set the scene here a bit. The data challenge is real for every organization around the world, and most of them are struggling to make actionable data available to those who need it, when they need it, and let alone turn that into business value. And research suggests that only 10% of business relevant data is actually used for analytics. And executives are struggling to turn that data and that insight into value, because only 32 say that's something they can really achieve. But even worse, 24% of business decision makers, they feel they don't have the skills to trust and take action on that data. So they need more data literacy. And that's basically what we do. So we want to engage our users to explore data in order to improve data literacy. And the more people that are using data, the more efficient an organization will be. And this underlines our engagement of making everyone in an organization as data literate as possible. We do this by, of course, providing knowledge and training around data analytics in general, fully technology independent. And we have some tracks with customers who we help to do more with data in a strategic way. On the other hand, we achieve our mission as well by providing the technology that fits most to our mission. And so far, this is mainly with ClickSense, because this technology really has a couple of core differentiators for us in this matter. Before we go a bit deeper in that technology part, let's first quickly introduce At Once as a company. So first of all, we are part of the broader Kronos group. Some of you might already know, although At Once is an independent company, being part of this group makes it possible for us to offer end-to-end solutions involving knowledge and people from multiple competence centers. And in this way, we could help already a lot of our customers on various topics, even broader than data analytics alone. At Once is founded in 2007, so almost 15 years ago, and has a strong focus on the Click data platform and added value products for it, like, for example, Vislib, Infinity Forms. But even in today's session, the Tangent Information Modeler from TangentWorks for predictive analytics. Our services are mainly project-driven, with a group of 15 dedicated Click consultants, and some additional freelancers. And apart from that, we have won already several awards, both locally and internationally. In 2019, this resulted even in the new EMEA Partner of the Year award, which we proudly received during a global event in the US. So why are we now using Click exactly to execute on our mission? So we work with Click because they deliver an open end-to-end platform which focuses on hyper-automating the data supply chain, and there are a number of key elements in Click's approach. This platform is open to any analytics use case, so wherever the data resides or wherever the compute needs to reside. And Qlik will work and engage in any cloud platform, supporting AWS, Azure, Google Cloud. Equally, any cloud that you want to deploy in, Qlik can support, including even their own enterprise class SaaS offering. And this capability takes data from any location and can move it to wherever we need it. The data integration platform supports that notion of change data capture and real-time streaming of data into target locations. And it enables our customers to fully automate the process of managing and curating data warehouses, and ultimately drives the notion of data lake creation, supporting the migration of data into cloud environments as we generate, deliver, refine, and merge data from all sources into the targets that are relevant for your analytics use cases. And the data integration platform continues to be open, so it will basically work with any BI tool and any analytics solution. Of course, we believe that Qlik delivers the best-in-class experience as well, and it supports a range of end-to-end consumption measures around self-service analytics, embedded analytics, but still guided dashboards and static reporting. And ultimately, the Qlik technology creates an active intelligence platform covering data alerting possibilities and even driving other systems via webhooks. And when we talked earlier about the data literacy and hyper automation, the Qlik data analytics platform comes even with a patented associative and cognitive engine that makes it very easy to understand and play with your data. It can automatically create data models based on data profiling, and it can even automatically generate insights and data visualizations on the fly without having someone in the organization creating those first. The catalog capability then sits between these two portfolios, and it bridges the world between IT and the business, connecting data from the data integration capabilities, let's say, and feeding it into the analytics environment, making it much easier again for business users to get access to the right data without avoiding the company's governance rules, because that's still important as well, of course. And what we didn't discuss yet on this slide is the right block, interacting with advanced analytics and data science principles. And one of the most well-known applications here is predictive forecasting over time and detecting anomalies in for example, production processes. And exactly the point where this webinar is all about. So far, we could only help our customers in proposing them data scientists to manually create forecasting algorithms and engineering corresponding models. And that works pretty fine for an individual use case, but becomes pretty labor intensive and expensive when you need to scale that across an organization's different use cases. And therefore, TangentWorks has a unique proposition in the market with their tangent information modeler. And TIM is a breakthrough automatic model generation technology in order to achieve accurate forecasting and anomaly detection. And I will now hand over to Sam Verdonk, who will explain TIM a bit more in detail. And then afterwards, I will show you more in detail how this technology works during the demo. So Sam, the floor is yours.
Well, thank you, Neil. So I'm happy to be here today. Sam Verdonk from TangentWorks. We recently started working with At-Once. And I hope in the next coming slides and few minutes to take you through that, the value we add to BI in general, and so also to the Qlik environment and to the offering of At-Once. I think afterwards, what will be very interesting is that we've prepared a couple of demos to also show you what's possible and how your existing dashboards can be taken to a new level, potentially. Because when we think about BI, At the end, we see it as the art of making sense out of data, turning it into insights that are valuable to business. That's what it's all about. I'm not here for a technical data science talk. No, for us and for TangentWorks, it's about the business value, the use cases, and of course with the digital transformation, with big data, with more and more companies having their data sorted out and better organized, working with BI tools like Click, we are opening doors to many more use cases for predictive analytics. And if you look at BI today, we see that so far most companies, they're mainly looking at historical data. That's what's happening today. There's a connection to your historical data where you can analyze what happened, maybe diagnose why did it happen, and dive a bit deeper. And of course, there's a lot of value there. And this can be used for visualization, reporting. How much did I sell last quarter? Why did certain things happen in my production process? Very interesting, but much more value comes, or even more value comes from a predictive part, looking further ahead. What will be happening tomorrow, next week, or next month? How much will I be selling? What if I do my promotion at this price or at that price? Scenario planning, what if analysis? What if that trend continues? So why is it continuing? Where will I be next week? So adding that predictive layer to your existing BI environment, that's powerful. That's where there's a lot of business value. And that's what we, on the next slide, as TangentWorks, are focusing on. So TangentWorks, we are a Belgian company, a scale-up company today, growing quite rapidly, and we're really a technology vendor. So while At Once, of course, is focusing on end-to-end solutions, supporting you with your data projects, we have basically built a technology, quite unique one, which I will take you through, and we run those operations from R&D commercial offices in Europe, but we also have local support and business development offices in the US, in the UK, and expanding globally. But our mission is to make time series predictive analytics easy, automated, and accurate with instant machine learning. Now, I will be explaining those couple of words a bit more in detail in the next slides, but we do that together with partners, and including At Once, because at the end, it's about an end-to-end solution which we want to provide. So what we do, on the previous slide, I mentioned predictive analytics for time series. So what's that about? Yeah, you can start doing predictive analytics using statistical traditional methods, or using AI-powered machine learning on different types of data sources. You can do document handling. You can do predictions on images, image recognition, on sound, on video. We decided from the beginning, when we started around 8 years ago, to focus on one specific type of data, which is time series data. Basically, every data set, you can imagine a spreadsheet, an Excel, a data set which has a timestamp as one of the columns. So it's data against a timestamp. Maybe your sales of your product every hour, or your vibrations on a machine every second. It can be hourly data, second, minute, weekly, daily. That doesn't matter, but that's time series data. And why did we choose with our technology to focus on time series data? Because that's where the most use cases are. There's a lot to do about AI, and then fancy talk about self-driving cars and image recognition, these kind of things. But day-to-day businesses, they are usually not doing that. What are day-to-day businesses doing? Everyday businesses, they are trying to plan their sales and their inventory, their production, and forecast consumption, and try to set prices and cash flow planning. And much of that is based on time series data. But time series data is challenging. Why? Because you have the notion of time. there's constantly new data coming in, and that data can change over time. Your sales can change over time, your production, you're producing certain products on a production line, and tomorrow you have a different product on that same line. But that different product is creating different vibrations and pressures and temperatures. So it changes. You constantly have changes in that data. On top of that, data points might be missing. You're expecting certain data input because your sales is, for example, impacted by the weather. You are selling more if the sun is shining, could be, but the weather data is not coming through. Normally, a model to predict something is expecting certain data input. If that data input is not there, the prediction fails. It doesn't work. So those are challenges in that kind of data. Maybe you're expecting data every minute, but it's not really exactly like that. Maybe data is coming in after 59 seconds, 61 seconds. On top of that, with time series data, what do you usually want to do? Usually three things. Either you want to look forward, you want to forecast, look ahead, or you want to look for anomalies in your data, or potentially you want to classify events in the data, right? But if you want to forecast and look ahead, you often want to do that for different horizons. You want to forecast the next hour and the next day and the next week. So why am I saying this is because, so it's challenging, that this type of data, but it's also, you often need a lot of forecasts. It's not usually about having one forecast, one prediction. It's quickly about a lot of forecasts for different products you want to sell, for different production lines or different machines, could be, and for different horizons, 1 day ahead forecast, 1 week ahead forecast. So you need a lot of predictions, and you need to have them adaptive. They have to be flexible, it has to be dynamic to cope with those changes in the data and the missing data points. And now that's what we focused on. Today, there's already a lot of descriptive and diagnostic analytics going on, but we wanted to democratize the use of predictive analytics and prescriptive analytics. That's what this talk is about, and on the next slide I will go a bit more in detail there on how that compares to other techniques. Because today, if you want to start with predictive analytics, say you want to take your forecasting to a new level, basically the main approaches are here, the two on the left. The handcrafted modeling is still the most used. It's the academic scientific approach. You hire a team of data scientists, data engineers, so experts, a team of experts that are not always easy to find. You give them the right tools, and in coding tools like in Python and R, they can get started. They prepare and clean the data, and they start feature engineering, model building, model tuning, backtesting, model selection. That's typically what they have to do to start building a predictive model, which can be used to forecast or do anomaly detection. But to do that, they usually have to take several loops through this process to get to a good model. They train the model on historical data and then test it on new data. And if it works on the new data, it gives good results. That model can be wrapped in an API and used in production to, for example, every day predict the sales of the next day, or the demand of certain products for your inventory planning and your production planning, these kind of things, right? It's a good approach. It exists since a long time, but it's very expertise driven. You need the right people, and they need a lot of time. Usually we see that to have one model in production with this approach, it takes a couple of days to a couple of weeks, making it not very scalable and quite expensive. So usually companies who do that, they only do that for the most important use cases, and they have a big budget for that. Now, we're not the only ones who saw that a level of automation there would help. So the second column, it's about AutoML, and maybe some of you have heard about AutoML. It's a big hype in the past few years. AutoML are platforms usually like Data Robot or Azure Machine Learning, and a lot of the big vendors from SAP to IBM and also data platforms like Alteryx, they have an AutoML strategy and offering. But what happens with AutoML? Basically, they follow the exact same process as a data scientist, but they bring in the force of computing power. So what do? You still have to clean your data, prepare your data, but then they use brute computing power to basically you connect your database and to push your data set or database through 10, 15, 20 different kinds of algorithms to automatically run like a competition and tell you which algorithm to use. Because to build a predictive model, there's basically two key things you have to do. You have to choose the type of algorithm you're going to use, like a neural net, a random forest. That's of course the technical stuff. That's why that's what the data scientists are focusing on. And then you have to do feature engineering, which is deciding which parts in the data impact the target, the thing you want to forecast when in time. So that algorithm decision is automated with AutoML. So brute computing power is used. You install a couple of servers, and if you wait half an hour, 1 hour, couple of hours in computing time, you get a result, and the AutoML platform tells you, for this use case, you best use a neural network. But then you still need an expert to then understand what that is, a neural network, and to do the feature engineering, the tuning and the testing of the model, to then wrap it again in an API and start using it in production to do forecasting or anomaly detection. So it's the same story, but it speeds up the process quite a bit. So with AutoML, you go from days or weeks to hours to a couple of days to have one model in production. But for BI, that's not enough. For a business planner, a business analyst, we think we can do much better. So that's why we came up with TIM. TIM, the Tangent Information Modeler, it's an engine running in the cloud, a REST API that can be very flexibly deployed and connected to, for example, Qlik, to do real-time automatic, hyper-automated, a word already mentioned by Neil, hyper-automated predictive analytics, mainly forecasting, anomaly detection. So we have two approaches there, which I will not talk about in too much details today. We can do that later. But with instant machine learning, you have your data set ready. Your data is, for example, in Qlik. And in one step, we will train a model automatically, fully automatically, one push of the button. We train a predictive model on your historical data. Step two is that model, which is now existing, is used on new data to make a forecast or anomaly detection. These two steps, they take a couple of seconds to maximum a couple of minutes. We're not talking days anymore. We're not talking hours. We're talking seconds to minutes, real time to almost real time, right? And that's always through a single API. So you always talk to the same engine, because TIM, in fact, it's a model building engine. It's a product that builds those predictive models for you in a hyper-automated way. The second approach is, okay, with real-time instant machine learning, we took it even one step further, because with all the three other columns, all the three other approaches, you build a model now, you train it on historical data, and you only start using it on new data weeks or months from now. I said, yeah, maybe we can do better. What we did with real-time instant machine learning is every time a new data is available, maybe every hour, every minute, or every day, our engine is triggered to automatically build a brand new model. So no model training anymore. We build a brand new model on the spot. We automatically deploy it to make a forecast. So the model becomes a byproduct. It's all about the final result, which brings the business value, which is the forecasting or anomaly detection. So how does that differentiate? On the next slide, where do we really, what are our key strengths, let's say? We call this the instant machine learning revolution. In the beginning, we also called ourselves AutoML. But then we were helped by analysts who said, yeah, but basically TIM is doing something completely different. Your approach to data is completely different, and the result as well. And that's why we started calling ourselves Instant Machine Learning, and we hope you want to join us in the Instant ML revolution. And there's good reasons why you should. Mentioned here on the bottom, it's basically we found a way to automate much more of that process. Not only the decision on which algorithm to use, but we also found a way to automate the feature engineering, the model tuning, and the training and all of that. And that's super unique. And that high level of automation at no code, no Python, no R, makes it very easy to use. And on top of that, it's super fast, ideal for BI dashboards, where you have a dynamic environment, you want to get updated as a business planner, business analyst on your demand, on your sales, on your production, your maintenance, and so on, to better plan that, to get real insights. But of course, we are also accurate. So the main innovation we brought is that we found a way to automate that feature engineering. And I don't want to go into too many technical details, but that's the holy grail to us. To make a good forecast, time series prediction, forecast, or anomaly detection, you need to very well find patterns and correlations in the data. And this usually it's expertise intensive. It takes time, it's complex. We found a way through the mathematics we've applied to automate that. And we've also written white papers and even a book about that, which we can share afterwards for those who are interested to understand better how we are doing this. But at the moment, you have to believe me that we do give very accurate results. That's our reason of existence. So we basically, the first few years, we've done almost nothing but competitions and hackathons to prove ourselves, to prove and benchmarks that this system works, that building models automatically and so quickly that it gave good results. And more about that later. But that's super important, of course. But on top of that, our approach to the data and instant machine learning turned out also to have two other very big benefits. First of all, the results we give are explainable. There's a lot of comments on machine learning that you give a prediction, but it's a black box. You don't know what that forecast, how that forecast came to be, how it was created. And a lot of companies don't like that. A very nice side effect of instant machine learning is that we give fully explainable AI, fully explainable insights. You don't only get a forecast, you also get full insights on how that forecast came to be. So what were the different features that were created and which data is impacting the forecast the most. And this will also be shown in the demos. Last but not least, it's flexible. Very flexible to first deploy. This product can run, Tim can run on our engine, on our environment. We provide it to you as a SaaS on Azure or AWS. It can run with At Once. They can host it for you, or it can run with you on your cloud or on your premise or even on the edge. On top of that, because it's a single API, we can change with the data. Let's say COVID. For us, Corona now, COVID is great for business because a lot of models at a lot of companies, they failed because the model is expecting certain patterns, certain trends, and suddenly the consumption, the human behavior, the sales, everything changes. So these models, they just give an error, they give bad results. Because we have a single API, we can adapt to changes in the data. If suddenly the data is completely different, we saw this like with Elia, which is one of our customers. Electricity consumption with the first lockdown was suddenly 15% lower than normally. All their models failed. Our engine, Tim, just sees, oh, this is a completely new environment, reality, builds a completely new model, not the old model that was trained, just a completely new model, focusing on that latest new evolution to start to give a good forecast again automatically, quickly. And that's amazing. So on the next slide, I want to explain that accuracy and speed up in a bit more details, because having a robust process that is capable to cope with changes in the data, with structural changes, that is scalable, that's amazing. I think we believe that's super important. That's also explainable. But of course, for a lot of business value and use cases, the speed and accuracy are probably the number 1 and 2 most important things, right? So this is just an overview of all the benchmarking we have done. So a big number of competitions. And what we basically see that when we compare TIM against data science teams, data engineers, like in the 3 competitions here on the left, we are usually getting the same results, so the same accuracy, fully automatically within seconds to minutes, against models they've been working on for days or weeks. Sometimes we are a bit better, sometimes it's the same, on par or a bit less, but it's similar in a fully automatic mode. Compared to AutoML, like the capabilities in Azure Machine Learning or Alteryx, we see that our approach works much better. Of course, these platforms, they work with many other data types. They're much broader platforms, yes. But for time series, for forecasting, for anomaly detection, instant machine learning works better. Much greater speed and a much greater accuracy. You see here a delta of accuracy that is 2 to 5 times better, a speed that is 10 to sometimes 250 times greater. And this is now a tool you can just add as under the hood as an additional layer to your Qlik environment to also dare add those accurate and fast predictions. I want to dive on the last few slides, so the next one as well, a little bit deeper on the use cases. I can talk for 2-3 hours on the technology, but that's not what it's about. It's about the use cases in the business. And there we really started commercially 4 or 5 years ago, mainly in energy utilities. That's where we started. Lots of use cases there for forecasting, energy consumption, heat consumption, gas and electricity, production as well with wind and solar, the price setting because it's an open market. It's lots of use cases there. We grew a lot in that market. And in the last 2-3 years, we expanded to other verticals because our tool is generic and time series are everywhere. So today, instant machine learning is being used for use cases in manufacturing, like remaining useful life forecasting and in predictive maintenance, looking for anomalies in production quality, energy management, and so on, in a lot in retail, supply chain, CPG, demand planning, staffing optimization, also sales forecasting I've mentioned, but also cash flow planning, promotion planning, marketing analytics. In healthcare, the capacity planning, for example, also supplies in hospitals, for example, and the prices of those supplies, and in banking and finance, where there's typical use cases like payment, forecasting, and exchange rate predictions. So a lot of options there. At the end, the business outcome, the value for you, usually comes from the 4 points at the bottom. Of course, one key thing is having increased revenues or cost reduction in supply chain, for example. It's often about having less waste, more efficient logistics, etc. Optimized staffing. But then, of course, you also focus on the operational excellency, the customer intimacy, especially with marketing analytics. And last but not least, the risk management, the risk mitigation. And I think that's super important. One of the key benefits we bring on top of the revenues is that you have a robust process. A lot of customers choose to work with us because at the end today, they are doing forecasting based on human experience, on expertise, based on the experience of people that might leave the company, not on their data. We want to make it possible to do more predictions based on data. And 2 examples, that's to end my talk. So on the next slide, first example is Bimbo Bakeries. That's one of our biggest customers in the food industry. You could also call it retail supply chain, CPG. This is a company that has, it's the biggest bread bakery, basically, manufacturer in the world. They have 60-70 bakeries in the US. It's a North American company, mainly active in Canada, US, Mexico. They have around 11,000 outlets, so a big organization. They make the buns for McDonald's. They make bread which is sold all over Walmart in the US. Now their challenges are, they wanted to reduce waste, of course. Their products go to waste quite rapidly. They want to optimize their logistics, and they mainly wanted to sell more. They want to have the right products available in the right outlet at the right time. So basically what they wanted to do, they wanted to improve their demand planning by having demand forecasting on a product level. Today, they are already doing demand planning, of course, but they were doing it per product family because they didn't have the tools, the technologies to do much more forecasting. Forecast the sales for every product, maybe in every region or even in every outlet. But then you quickly talk about not 10 models and forecast or 100, but 100,000 of models and forecast. And in their traditional supply chain planning software, that was not possible. So what did we introduce? They were a Qlik customer already. They were using Qlik dashboarding, and we brought their demand planning and demand forecasting to Qlik together with a local partner. So now they're using instant machine learning in Qlik to forecast their demand and have thereby less waste and an optimized distribution of their products. Another final example before we go to the demos is enterprise rent-a-car. I think that's also quite a nice example in logistics and distribution. So yeah, they have also, I think 30, 40 locations, more than 3,000 vehicles and drivers, of course. And they have to make sure that they have the right cars available at the right location at the right time. They have to plan maintenance, but also staffing and so on. They were before doing this planning mainly based on human experience with a couple of relatively simple calculations in spreadsheets. Yeah, we basically did a proof of concept with them, and for 3 months we ran in their BI environment Tim against next to their existing forecast. And they quickly noticed after 1 month already that our forecast that also took weather into account and different things were 10 to 15% more accurate. A lot of value there, better planning with less resources. 10 to 15% more accurate, and we had a more robust process because now the forecast is based on data and less on human experience and expertise. So these are some examples, some ideas of where instant ML can really bring value. And I would now like to give the floor back to Neil so we can show you a couple of demos.
Yeah, thanks Sam for the introduction of Tim, and we'll now indeed dive into to the demo part and show you how Tim works both in Team Studio and in QlikSense. So let me quickly share my browser to you. So I guess you can all see it right now. So there are two flavors, let's say. One is the Team Studio, which is basically a product hosted by TangentWorks themselves, and which is a data analytics independent product, let's say. So you don't combine it with, for example, QlikSense or any other data analytics technology. It's just a standalone project, and you can add certain data sets here in the format of CSV files or whatever you like. And then basically what you do is just adding a new, it's not a new data set, it's basically a new use case. So it's this one. And then basically I want to start, for example, with the demand demo. I can just put a couple of things. Of course, the most important thing is what will be my target for the prediction. So what do I really want to predict in the future, or do certain backtesting for which metric? So that's something we need to select here. And then you can, of course, still describe something about your experiment, the business objective, business value, the KPIs, etc., which can be done later on. And then basically what you see is here you see all the different data points plotted over time. And in this case, it's all based on the demand. I can then here put certain backtest length, for example, to see from how did it go before. So I can put here, for example, 72, so then it will go back 72 hours, and I want to predict 72 hours in the future, for example. I can still here select or deselect certain predictors, but again, that's not necessary because Tim will just automatically detect the importance of these predictors and adjust accordingly. So if there is a predictor that should not be taken into account, let's say, or is not really useful for the model, then it will not take it into account anyway. So if I then start building this model, then here at the bottom, you will see that it's started building, and now it takes a couple of seconds, of course, to fully build from scratch this model. It will read all this data. It will detect or it will create, let's say, the forecasting models, etc. And then basically after a while, so in this case, after 14 seconds, we got our insight. So I can now zoom in this scenario and see basically here, for example, yeah, how different it was, our forecast in this scenario versus what we had in our actual line. And then we see that it's, in my opinion, it is pretty accurate here as well. So it does it for the complete data set, the test itself. And then, of course, our 72 hours as a forecasting result. This is just the chart view. Another thing that's very important is that the forecast itself is really explainable. This is something where we are struggling with in the past, or were struggling with in the past as well. And this is where Tim really brings a good solution in place. In this case, we see here, for example, our predictor importances. So in this case, we see that demand counted for 62%, while, for example, the temperature itself was taken into account for 13%. This is all on an average level, because basically what Tim does, because it's your hourly data, it will also regenerate that model automatically for every hour. So it might be that these importances are different during this different hours. So for example, if I zoom in here to 1 hour, then we see that it took for 25% the demand of 168 timestamps back, while the same demand 2 timestamps back counted for 8%. And you still have a lot of other things like day of weeks, holidays, and of course, the more predictors you have in your data, yeah, the more accurate your forecast can be. That's for sure. This is how it all works in the Team Studio, so fully independent from any Qlik or from any data analytics technology. If we then go to, for example, an example in Qlik itself. You heard Sam talking about 2 things, so the anomaly detection and the predictive forecasting. This is basically about the anomaly detection. So we have here, let's say, the rotor things, and we are just trying to check from what are now anomalies in our data set. And in this case, we've started or we trained the model starting from beginning of 2018 towards October 2018. And then the detection itself should be from for the full month of December. And I can then, for example, enlarge this chart here a bit and see immediately what comes into play. So here we see immediately what kind of anomalies that Tim actually detected, and it will be visualized in your ClickSense charts. I can even say here, for example, but I want to detect this starting from October as well, and then it will just automatically regenerate the model, recalculate all those things, analyzing that data, all those kind of things. So that's basically what's happening now. So it's calling the APIs towards the TIM engine, and then it will be providing me a result in a couple of seconds. Let's not wait here for it to show. It will just show up with all the different other time slots as missing here, let's say, on this chart. I'll show you later on again when it's fully calculated. But I still have another example in ClickSense available, which is basically about the COVID-19 vaccination part. So in this case, we see, for example, normal ClickSense dashboard where we can interact with. For example, I'm interested in Flanders and Brussels. And then basically I want to go with this selection towards another sheet called of my hospitals. And basically here I still show my weekly hospitalizations, so daily in hospital, in intensive care, respiratory, all those kind of things. And basically what it's calculating here right now, and maybe I still had to wait for my wind turbine to calculate fully on my engine. Yeah, well, let's deactivate this one for now, and then let's fully wait here. So basically what we see here is that there is, of course, our graph with daily in intensive care. And then here we are mainly forecasting. It's mainly a backtest, let's say, of 7 days, and how our forecast looks compared to what we would have seen in our actuals. And in here we see, for example, our predictor importances. And what I can still do here now is see from, okay, but I want to show this, for example, for Antwerp. And then it will again automatically recalculate it. You see that, for example, now one predictor disappeared, and that's basically because Tim automatically detected that this predictor is not important anymore for Antwerp in this scenario, so it will of course not take it into account anymore. You will even see that it's here now more accurate. Again, the accuracy of your forecast fully depends on the quality of your predictor candidates, of course, that you include. If I want to add Brussels to the selection as well, again, it's fully calculating, and then we are even almost exactly on online, let's say. So that's basically what I wanted to know. It's just another thing maybe for the more technical people around. How will it now look in an expression? Is it really complicated to add here? And that's certainly not the case. So if I, for example, show you how such an forecast expression might look like, then you will just see that it's one function that we call. Of course, this is the forecast function, but there are multiple functions related to the API of Tim. We just provide the dimension, so the date dimension. We provide the forecasted value that we want to achieve, and then of course combined with all the different predictor candidates in our data set, we say where it needs to start with the forecast, how long the forecast should take. This is just a variable to activate or not activate, and then just provide certain labels to it, and then we can get the result back from Tim. So to be honest, it's not really complicated at all in ClickSense. That concludes my demo for now. Let's then quickly go back to the slides. I just have one slide left, and that's basically about the starter packs that TangentWorks and At Once offer for our customers. And as you can see, it's for multiple data analytics solutions, so not even limited to the ones listed on this slide. But the most important one for now is, of course, the TIM for Click package, which includes 1,500 forecasts to be performed during a 3-month evaluation period. And this pack also comes with some kind of success services, including instructions, tutorials, but even onboarding sessions. So pretty nice, to be honest. And that's it for today. I hope everyone enjoyed the session and got inspired in how to move on with predictive analytics. And now it's up to you to think about what kind of use cases are valid within your organization, and where TIM can really play a crucial driver of. And yeah, of course, we are happy to get in touch with you to further discuss. And you can always contact me via my details on this last slide. I'm not sure, are there any currently any questions asked, let's say, in the Q&A panel that we need to address? Let me quickly check on that. I see here one question coming in. So are there any other possibilities than predictive forecasting and anomaly detection? Yes, there are, and maybe Sam, that's something where you can assist with or explain a bit more.
Yes, definitely. Yeah. So we have developed a use case library, which is probably interesting to look into. And there we also, we try to make the link for different business use cases. What do you there need? And often forecasting is the way to go. We see forecasting for a lot of typical business use cases is still what we see most. But sometimes it requires classification. You want to basically put the result in, classify it in, for example, okay or not okay, quality of a product, for example. So that's also possible, and anomaly detection as well. But the classification part is maybe not really highlighted today, but that's definitely something we can discuss. And in general, something we like to do is to hear about your use cases and to try it in TIM, because the very nice thing is because it's so easy, so quick, it's also, you can directly get started with your data and give it a shot and see if there's any predictive value in your data.
Okay, thanks, Sam, for that clarification. It seems I don't see any other questions popping up. So I think this concludes it for now. I still got another question. Is it dependent on the version of Click, ClickSense Enterprise, ClickSense Business, the SaaS part of Click? I do believe, Sam, that in this case it's valid fully for the ClickSense Enterprise version. And I think it's currently a main limitation of the ClickSense SaaS environment that it's not available there, but that's something where basically Click is working on to enable that very soon in the SaaS environment as well. It's mainly about the advanced analytics part, of course, which is in the roadmap of Click itself. Yeah.
Yes, exactly, indeed. We have to follow the roadmap as well. And it's also indeed, as Neil mentioned here, that today the talk is mainly about Click, which I think makes it's one of our strongest integrations of our technology with the data platform. But also if you would be using platforms like Power BI, Alteryx, Data Factory, Databricks, Snowflake, and so on, Yeah, at the end, we are only an API call away. Yeah? Our engine is very flexible to be deployed and integrated. So there's a lot of options there.
Yeah. Okay, good. No other questions. So I think this wraps it up for today. Thank you everyone for listening. Thanks especially Sam for joining us today and explain a bit more about the tangent information modeler. And probably we will hear from you very soon about what kind of use cases you see within your organization. And of course, as being said before, then we are happy to fully assist with that. So thanks again, have a nice day, and talk to you soon. Bye-bye.